Hi guys, hello. Hi guys, welcome to NEET World Institute and NEET World YouTube channel. And yes, I hope you guys are doing well for the EAPCET preparation, right? For upcoming year, that is 2026. And many of you guys are applied for this JEE mains also, right? And the medical stream guys have been applied. I'm going to apply for the NEET also, right? Yes. So the thing is, this series is particularly for EAPCET aspirant. Okay. Yes, it's for both engineering streamers and medical stream as well. Okay. So one more major advantage for the NEET aspirant is when they are watching this physics for EAPCET 2026, they can get knowledge for the NEET also, right? Yes, like EAPCET is also not an easy exam to take, right? It's also one of the good exam where they can get a good colleges, right? No, yes. Then till now we were talking about the lesson system of particles and rotational motion, right? So wherever we left in the last class, we will continue with the topic. Okay. So let's wait for 1 or 2 minutes. The people are joining over here, right? Then we'll start the class. Okay, so let's start the class. And one more thing, guys. Okay, so we are going to be live from December 12th for IP examination also. Okay, so we will intimate the timings. So at which time which class is going to be happen. So it's for everything like physics, chemistry, botany, zoology, mathematics, right? And if you want to attend the offline classes, you can call to the number which is scrolling down in the screen. Okay, or we will give the number in the description box. So you can call to that number and you can register yourself for the offline classes. So it's going to be held from December 12th. So we are going to do each and every lesson like easy question to difficult question. Okay, and we will cover the miscellaneous problems which are going to be asked also, right? Then we will see like 5 to 6 model papers for both class 11th and class 12th in every subject. Once every chapter has been completed, we will do the model papers. So this will be continued until your IP exam starts, right? Okay. And one more thing, like you can register yourself for offline classes of EAPCET 2026, right? So it's already started. So there is still time. You can cope up with the topics whatever we have completed. Okay. So let's start the topic, right? So yesterday we were talking about, in last class axis, precision, center of mass, right, and motion of the center of mass, everything we were talking. Now the next topic is, yes, in the previous topic we were talking about linear momentum of a system of the particle. Now the next topic, conservation of linear momentum. When we talk about this conservation, the meaning of conservation is like I'm conserving something, I am not wasting anything, right? There is no wastage. Like conservation of energy. Conservation of energy means like the one kind of energy has been converted to other kind of energy. For example, kinetic energy is there and potential energy is there, right? So kinetic energy has been converted to some other kind of energy. We can say it's a potential energy. Okay. For example, I am throwing a ball. Okay. After reaching maximum height, energy will be there. That energy is called as potential energy. After reaching the ground, while hitting the surface, the energy will be converted to kinetic energy. Well, when it travels only, the potential energy will be keeps on converting to kinetic energy, right? So the same thing, conservation of linear momentum. If external force acting on a system is zero, that is F external is zero, then dt by dt will be equals to zero, where momentum is constant if there is no external force is acting. Okay, so here is an example. Okay, so here consider a heavy nucleus which is radium moving with velocity u. So here u is the initial velocity, right? Initial velocity, and it split into nucleus, radon, and an alpha particle. Two particles has been split. So here F external is zero, which means momentum is conserved. Center of mass of the system continues to stay in the same straight line. When I am moving in a straight line, if someone is disturbing only, I will either change my direction. If no one is disturbing me, I will keep on moving in the straight line only, right? Center of mass continues to move with the same velocity u. Okay, so this is the concept of conservation of linear momentum, right? So now we are going to the next topic, vector product of two vectors. When we are talking about work energy power, there is a main thing, like when two vectors are multiplied, either it's a dot product or cross product. Yes, it's a dot product, right? Dot product. Then the resultant will be a scalar. Here, when two vectors are multiplied, that is a cross product. Okay, we are doing a cross product. Then the resultant also will be a vector. Okay, the vector product of two vector A and B is a vector C. Vector A and vector B gives a resultant also vector. When it is applicable, yes, it's when we are doing a cross product. Cross product. Okay, so A cross B will be equals to AB sin theta, and this n cap is nothing but unit vector perpendicular to which both A and B, right? Yes, right hand screw rule. Right hand screw rule is nothing but, see, I am going from A to B. For example, this is my x and this is my y. Okay, I cap, j cap. So I am going from I to j, the resultant will be k, like it's outside. It's outside. For example, I am going from j to I, resultant will be inward. Okay, it will be inward, right? So outward, inward. So this thing we can understand from here, that is I cross I will be 0. Why? A cross B, like A vector cross B vector will be equals to AB sin theta. AB sin theta. When I am talking about I and I, both are in the x-axis. Both are in the x-axis, right? Angle between them is 0. So sin 0 is 0. Okay. J cross J I cross j, j cross k, k cross I. What will be the answer? So from here we need to use the right hand scroll rule. That is nothing but simple concept we can remember. I, j, k. I to j resultant will be k, j to k resultant will be I, k to I resultant will be j. So I need to take clockwise as positive, anti-clockwise as negative if I am going in the reverse manner. So I, j, k. So one more thing is I, j, k only we are talking. When two terms are there, the other term will be the missing term. Okay, j, k is there, missing is I, k, j, k, I is there, missing is j. Now after this I can see the sign. Okay, am I going in the clockwise direction or anti-clockwise direction? Okay, now the same thing if I write j cross I will be equals to minus k, k cross j missing is I, but I am going in reverse manner, so minus I cross k, I am going in reverse manner, that is minus j. That's it. Okay, this is about the cross product of the unit vectors. Unit vectors. Oh, sorry guys, like I guess it's clear now. Okay, I hope it's clear. The camera is clear now. Okay, now understood, right? Yeah. So next is a cross b, that is AB sin theta. Sorry. Yeah. AB sin theta, and b cross a will be minus AB sin theta. Because no, like when I am talking I to j, it is outward, it is positive, j to I, it is inward, it is negative. So a cross b will be AB sin theta, whereas b cross a will be minus AB sin theta. That's it. A cross b will be equal to minus of b cross a. Okay. So the vector product is not commutative, whereas scalar, yes, it's commutative. So vector product is distributive. So a cross of b plus c is nothing but a cross b plus a cross c. If two vectors having same magnitude and same direction, then the resultant will be 0. The resultant will be 0. I cross I 0, j cross j 0, and k cross k also 0. Done? So vector product of two vectors, like if two vectors a and b are perpendicular to each other, then a cross b will be equals to ab. Why? Because sin 0 we know that 0 only, sin 90 it is 1, right? So I cross I, so I cross j will be k, j cross k will be I, k cross I will be j. So the reverse manner, j cross I, k, k cross j minus I cross j, and I cross k minus j. Okay, if you remember the trick I, j, k, if you remember this trick, it's easy to analyze the vectors. Okay. So the next one is, suppose two vectors are given. So what is the product of the two vectors? Okay. So simple thing I can explain. Easily you can do the problem for this. Okay. Now, for example, A is given as ax I cap plus ay j cap. I guess it's visible. Yeah. Plus az k cap. B is equals to bx I cap plus by j cap plus, sorry, one minute guys. Wait for a minute, it's restarting. Okay. So, okay. Yeah. I guess it's clear, no? Camera is clear, right? I mean, okay, fine. Yeah. So let's continue where we have stopped. Yeah. So the thing we are discussing that suppose A is given as AX I cap plus AY j cap plus AZ k cap. B is equals to BX I cap plus BY j cap plus BZ k cap. Now they are asking the dot product A cross B. So no need to confuse yourself. Simple thing, take a dot. Okay, I cap, J cap, K cap. Right? Plus, minus, plus. So whatever is there like AX, AY, AZ, BX, BY, BZ. Right? Now, so I is positive, right? So plus I minus J, that is J is negative, minus J plus K. So when we are calculating for I, close this. Close this. So what are the remaining things are there? AY, BZ, AZ, BY. So cross multiply this. AY, BZ. AY, BZ minus, again cross multiply this too. AZ, BY. AZ, BY. Right? AZ and BY. Now, when we are doing for J, what we should do is close this J. So remaining is AX and BZ, AZ and BY. Sorry, AZ and BX. So AX, BZ minus AZ, BX. So similarly for K also. So for K, what we should do? AX and BY. AX, BY minus ay bx. That's it, right? That's it. So easy to remember when we are doing like this. This easiest method to follow for the cross product of two vectors. Okay, so here is the question. Find the scalar and vector product of two vectors where a is given as 3i minus 4j plus 5k, and b is given as minus 2i plus j minus 3k. I need to find both scalar and vector product of the vector, which is a dot b, a vector dot b vector, and then a vector cross b vector. Both I need to find it. This is the question. So can you give answer for this question fast? So whoever watching in online, no, like they also can give answer in the comment boxes, so that we will verify the answers. Okay. Yes, fast. Okay. Okay, dot product completed. What about cross product? I need both answers. Done? Okay, fine. You got the answers for the both the things. We'll cross verify now? Okay. We'll check whoever answers correct. Done. So now, first one, we'll find what is the scalar product, okay? A dot B, right now? So when I talk about A dot B, 3i minus 4j plus 5k dot minus 2i plus j minus 3k, right now? So 3 minus 2 is minus 6, minus 4 plus 1, plus 1, no, minus 4 plus 1, it is minus 4, 5 into minus 3 is, it is minus 15, so it is 21 and 25, so minus 25 is the answer for the scalar product, right? Then what about the vector product? Right now we have done for the scalar product, we'll see for vector now. So A cross B. Now what I should do, first I need to write I, J, K. Then plus, minus, plus. Right? So what are the numbers are there? 3, minus 4, 5, minus 2, 1, minus 3. Now when I doing for I, minus 4 into minus 3 is 12 minus, okay, now 1 into 5 is 5, minus j into 3 into minus 3 is minus 9, minus 2 into, like minus I need to write as it is, okay, minus 2 into 5 is minus 10, so minus of minus 10 it is, right, plus k into 3 into 1 is 3 minus 2 into minus 4 is 8. So now the answer will be, yeah, I into how much it is 7, 12 minus 5 is 7, minus j into minus 9 plus 10 it is 1, plus 3 minus 8 k into minus 5. So answer is 7i cap minus j cap minus 5k cap. So this is my answer for the vector product. Now scalar how much? Minus 25 we got. 3 into minus 2 is 6, minus 6, okay? Minus 6. Then minus 4 into 1 is minus 4. 5 into minus 3 is 15. So total 25. Minus 25 is the scalar and vector product is 7i cap minus j cap minus 5k cap. Suppose they are asking what is the magnitude of the vector product. So magnitude in the sense a vector dot b vector, like I need to take the modulus of that, which is nothing but root over 7 square plus minus 1 square plus minus 5 square, which is nothing but root 49 plus 1 plus 25. So root 75. Root 75 is the answer. Yes, you can simplify this further. Right, you can simplify this again further. How much we will get? 25 is, 5 is 25, 25 3 is 75. So 5 root 3. 5 root 3 is the answer when we are talking about the magnitude of the given resultant vector. Magnitude of the resultant vector product. Right. So this is how we will do the vector products. Is there any doubt? It's fine, right? Can we go for the next one? Okay. The next one we will go. Now, angular velocity and its relation with linear velocity. We were talking about linear velocity. Linear velocity is v is equals to displacement by time, right? Displacement by time. Then what about angular velocity? Angular velocity is nothing but angular displacement by time. That's it. Angular velocity denoted by omega. So omega will be d theta by dt. So where theta is angular displacement. So angular velocity is a vector quantity. Okay, it's a vector quantity. So how we will measure the angular displacement? It is radian. So what is the unit of the angular velocity? Angular displacement we will measure in terms of radian. Angular velocity radian per second. Okay, it is meter per second. What about this? It's radian per second. Radian per second. That's the unit for angular. Now, this is angular velocity. This is linear velocity. How we need to know the relation? Yes. So, S is equals to R into delta theta, which is nothing but when I talk about the theta, angular displacement, right? So, it has been covered some displacement here, right? In displacement in the r, like r, okay, and how much radius r. So S will be r into delta theta. When I differentiate with respect to time on both sides, ds by dt is equals to r into d theta by dt, where ds by dt, like ds by dt will be nothing but velocity, d theta by dt is nothing but angular velocity. So the relation is v is equals to r omega, where in vector form equals to omega cross r. Omega cross r. Right. So for uniform rotation motion, both magnitude and direction of omega remains same, but v will be changes continuously. Like angular velocity remains same, but whereas linear velocity keeps on changing. Okay, keeps on changing. This is about the relation between the angular velocity and the linear velocity. Right. So similarly, if we need what? Yes, the relation between angular acceleration and linear acceleration. So simple thing, if I differentiate this equation with respect to time, dv by dt, d omega by dt, okay, d omega by dt is nothing but angular acceleration, dv by dt is nothing but acceleration, right? We will see in the coming slide. Here, angular acceleration is denoted by alpha, the rate of change of angular velocity with respect to time. So alpha is equals to d omega by dt. Now we know the relation v is equals to r omega. Differentiate with respect to time on both sides. So dv by dt will be equals to r into d omega by dt. So dv by dt is acceleration and d omega by dt is angular acceleration, r into alpha. Right? So a is equals to r alpha, b is equals to r omega. These are the two relations which is important when we are talking about angular and linear relation. Okay, that's angular velocity relation, linear velocity relation. V is equals to r omega, and angular acceleration and linear acceleration. A is equals to r alpha. Okay, so what about the unit of the angular acceleration? It is radian per second square. That's it. Radian per second square. Got it? Okay. Now we are going to the next topic, that is moment of torque. What is torque means? Like moment of force, that is nothing but torque. Okay. So the the product of position vector and the force acting on a particle. For example, where we can see a live example of this torque is nothing but you are applying a force on a door. Okay. Suppose you are applying, for example, this is my wall. Okay. Here I have attached some door. Okay. I need to open the door. Where usually we will keep the handle of the door? Yes, exactly near to the end, like edge, right? No, where it has not been attached. So if I apply a force like either push or pull, I can open easily, right? But when I apply force in this place, I can't. Like I need to apply more force, right? No, I need to apply more force because the distance between the fixed point and the force where we are applying is less, right? If distance is increased, I can apply the force normally to open the door easily. Okay. Yes. Done? Okay. Now torque is nothing but r cross f. It's a vector product. So it is r f sin theta also we can say. Since it's a vector, no? So cross product gives a sin theta, dot product gives cos theta. So component of force perpendicular to the position vector gives the rotation about the axis. And the thing is, here theta also plays a major role. Theta also plays a major role. When you are applying a force in this point also, the angle is greater, you can apply easily. Like you are keeping the hand like this and you are applying the force, or you are keeping the hand like this perpendicularly and you are applying the force. Yes, there is a difference between them. Okay, so we'll see a problem on this. Let's understand how to do the problems. Okay, And relation between torque and the angular momentum, like momentum L is equals to R cross P, that's angular momentum. Okay, like when we are differentiating both the things, dl by dt is equals to d by dt of R cross P. Okay, when we are doing no, dr by dt cross P plus R cross dp by dt, we will get V cross P plus R cross F, where R cross F is nothing but torque, and V cross P, like I can say that P is nothing but mass into velocity again, right? So from this, V cross V will be 0, right? Same vectors 0, and R cross F is tau, that is torque. So dl by dt is equals to tau, where angular momentum, right? Torque is nothing but rate of change of angular momentum is equals to external torque acting on it. Rate of change of angular momentum is equals to the external torque acting on it. Fine. Yes. So torque and angular momentum for a system of particles. When we are talking about a system of particles, like n number of particles will be there. How to calculate that? So rate of change of total angular momentum of a system of a particle about a point is equal to sum of the external torque. I am talking about there is a system and there is n number of particles present there. So each particle will be having each like a single angular momentum, like L1 plus L2 plus L3 up to Ln will be nothing but sum of angular momentum is equal to the external torque acting on it. Okay, this is the formula. Now, conservation of angular momentum. If total external torque, we were talking about momentum and force. If yes, if force is external force is 0, momentum is conserved. Similarly, external torque is 0, momentum is angular momentum is conserved. Angular momentum is conserved. L is equal to constant. Right? Yes. Whatever things we were studied in linear, same, similar only in angular also. Right? Okay. So find the torque of a force F, that is 7I cap plus 3J cap minus 5K cap about the origin. Okay, the force acting on a particle whose position vector is, okay, whose position vector is I cap minus J cap plus K cap. So what I should do here now? Tau is equals to F cross R, right? F cross R. So formula same whatever we have done in the vector. Now you understood now why we were talking about the vector that much deep, right? So I cap, J cap, K cap. So 7, 3 minus 5, 1 minus 1, 1. Right. So get the answer, give the final answer for this question. We'll see. we have completed. Okay, let's see the answer. So I cap into, that is how much, 3 into 1 is 3, minus 1 into minus 5 is 5, minus j cap, 7 into 1 is 7, and minus I need to add it there. 1 into minus 5 is minus 5, so minus of minus 5 it will come, plus k into 7 into minus 1 is minus 7, again minus 1 into 3 is 3. So how much? I into minus 2 minus j into 7 plus 5 is 12, plus k into minus 7 minus 3 is minus 10. Right? Minus 2i cap minus 12j cap minus 10k cap is the torque of the given question. Right? So this is how we will proceed with the torque. So what is the unit of the torque? That is Newton meter, right? Force is Newton and position vector is meter. Newton meter. Got it? So with this we will end up the class of today's session. So we'll bring more interesting topic and questions in the upcoming classes. And guys, and one more time I will inform you that we are going to start the IP class for class 11th as well as 12th for, excuse me, yes, for upcoming year, that is 2026, on December 12th. Okay, so whoever has interest to join in offline classes, they can contact the institute. So the number is, which is scrolling in the screen, or else will be in the description box. You can contact the number and get the details of that. Okay, yes, we will be live also. Okay, so when we are in offline classes, like we are physically in the class, we will get good understand of that question, how we need to solve it. Okay, if you are having any doubt at particular time, at that instant we can ask the doubt, right now. Okay, so yes guys, we'll wind up and bye bye, we'll meet in the next class. Okay, bye.